Hi guys, thank you for watching my previous video. So today we are looking at a new chapter called Proofs in Plane Geometry. So without further ado, let me go to the next slide. So over here we have a question. The diagram shows a triangle ABC inscribed in a circle, and XY is a tangent to the circle at A, and we also know that AC bisects my angle BAY. Therefore, I have angle 1 equals to angle 1 labeled in the diagram. So I will start to find part 1. Triangle ABC is isosceles. So since AC bisects my angle BAY, therefore angle CAB is equal to angle CAY. And also, because of tangent chord theorem, I can also say that angle ABC is equal to my angle CAY, as labeled in red in the diagram. So therefore, angle CAY is equal to my angle CBA. I use tangent chord theorem. And by the way, let me correct my spelling. So tangent chord theorem is used here. So therefore, I can say my angle CBA is equal to my angle CAB. And because of this, they are the base angles of my triangle ABC. So therefore, I can prove triangle ABC is an isosceles triangle. Okay, so this is the concept you should be using here to prove triangle ABC is isosceles. Okay, next, part 2, we are asked to find or prove triangle AYC is similar to triangle BYA. So AYC is similar to triangle BYA. So whenever we do this kind of question, one triangle is similar to the other triangle, the best practice is to extract these two triangles out and match them point by point. So over here, I have already extracted out my triangle BAY, and I will label my angle correspondingly, because that will help me to see which angle is equal to which angle in an easier way. So now let me redraw my triangle BAY. And by the way, when you draw the triangle, it must be representative enough. So I've labeled my triangle BAY and the angles I know. Now let me draw triangle AYC as well and label the angle inside. So as you can see, I have matched them point by point, and I can see that they have two angles equal. The first one is my angle BYA is equal to my angle AYC, and this angle is common among these two. And next, my angle ABY is equal to my angle CAY, which we found just now. Therefore, with two angles are equal, my triangle AYC is similar to triangle BYA. And that is the end of this question. And I hope you grasp the idea. Now, let's take a look at this slide and a new question. The diagram shows a quadrilateral HIJK with L, M, N, and O being midpoints of each side. So quadrilateral means a four-sided polygon. And it needs not to be regular shape. And as you can see, M, N, O, L are the midpoints of each side. And we have to show that L, M, N, O is a parallelogram. So to prove L, M, or N, O is a parallelogram, we need to use the midpoint theorem, which is Mn. Let me link up all these points first. Let me link up L, M, N, O first. So by using the midpoint theorem, my Mn is actually half of Hj. And not only this, I can also say that my LO is also half Hj because of the midpoint theorem. And let's continue to use the midpoint theorem to find my ML and NO. So ML, or rather Mn, therefore is equal to LO. And next, let me find ML. ML is actually half of LK, or IK rather. And NO is also half IK. And because of this, my ML is equal to NO. So I have proved Mn equals to LO and ML is equal to NO. Therefore, LMNO is a parallelogram. Because for a parallelogram, opposite sides are equal to each other. And that's it for this question. And now let's take a look at a new question. And it says a circle passes through 5 points A, F, H, B, C, G, and these points lie on the circumference. And D and B are 2 points on AE such that AD equals to DB equals to BE equals to DF. So since my AD is equal to my DF, I know that this is a isosceles triangle. And also, I know that AD is equal to DB, therefore D is the center of the circle. And therefore I have already labeled in the diagram the angles in blue, they are all equal. And therefore I can conclude that triangle ADF is congruent to triangle CDB. Why? Because you have a few ways to prove this. The way I'm using is ASA. First, my angle ADF is equal to angle CDB opposite angle. And next, my angle DAF is equal to my angle DCB, angle in same segment. Or rather, then now I have my AD equals to my BD, which is given. So I'm using AAS to prove my triangle ADF is congruent to my triangle CDB. So now I have proved part 1. And part 2, we need to prove that triangle GEA is similar to triangle BEC. So let me label GEA first. So with all the points circled in green, what I'm going to do is I will extract these two triangles out so that it's easier for me to prove they are similar. Like the question just now, when you are solving this kind of question to prove two triangles are similar, the best practice is to extract these two triangles out and match them point by point. So now I have already extracted out triangle GAE. And now let me extract the smaller triangle BEC as well. And remember, you must match them point by point. Otherwise, it won't work and it's hard to see. So we know that angle E is common. So we just need to find the other triangle. It's the same. And with two angles equal, we can prove these two triangles are the same. I mean, others are similar. So our job is to prove one more angle is the same. So how can we prove the other angle is the same? So what I'm going to do is I'm going to prove my angle AGE is equal to my angle CBE. So angle GEA is equal to angle BEC. And this angle is common, like I said just now. And now let me prove angle AGE is equal to angle CBE. What I'm going to do is I see that angle AGE plus my angle CEA is 180 degree. I'm using angle in opposite segments add up to 180 degree. And next, I also see that my angle CEA plus my angle CBE is also 180 degree. And the reason is sum of angles on a straight line. So therefore, I can prove that my angle AGE is equal to my angle CBE. So with two angles being equal, I can now say that my triangle GEA is similar to my triangle BEC. And I hope it's not too hard for you to see as well. And this question is supposed to be simple. So I just have to write. Therefore, my triangle GA is similar to my triangle BC. So I have done this question, and I see there is still part 3 for us to find, but I would like to leave this as an assignment for you guys to see. And that's the end of today's lesson. Hope to see you again. Bye.